Well, good morning, everyone. Thank you for coming so early, so shortly after the party last night. And welcome. In this session, we're talking about sort of the innovations that you saw, some of the innovations you saw in the keynotes from Satya and Bill, and how was that actually driven in the back room. And it's a little bit the back room here. But our stuff tends to run in the back room, so it's a fitting scenario. And my name is Thomas Fenning. I run the file server group at Microsoft. And I also, for the Windows 8 release, was responsible for all the coordination of the continuous availability work across the different divisions. And that was a large project because continuous availability is not something one team can do. It has to sort of work end-to-end. So you really need to take a full look at the scenarios to make sure that sort of all the reasons that get in the way for your services to be available are being addressed. And so the talk is really directed at our partners. And it turns out if you take a garden variety server, there are certain things you can do with regards to availability, but there are special hardware requirements to really get that up to the levels that we wanted to achieve. And so we're specifically targeting the storage and server OEMs, ODMs, and then on the networking side, we have support for special NICs, and so we talk about that, and storage controllers. Once you have the boxes up and running, there's, of course, that little task called ongoing management, and we came up with a whole bunch of new APIs to make that really simple, because a big part of availability is that sometimes it's just too hard to get it. And so we thought about how we make it simpler. We'll talk a little bit about the motivations of how we came up with this program, or why did we sort of invest our resources the way we did. It's always good to understand sort of what's the potential market for these things. And so we did some very deep research on that, and it was actually very strong customer sentiment that this is an absolute must-have. A little bit we talk about the approach we use to drive all the features through the operating system. And we set out some core tenets and then stuck by them through, but made sure that everything works end-to-end. And then we talk about the sort of appliance form factors and the opportunities that exist. What we hope you gain from the talk is that you walk away with a good understanding of sort of the end-to-endness and like what are all the investments that we made and how that plays with the parts and pieces you can supply. The key focus is going to be on these virtualization and NAS appliances and sort of what those pieces all are. And so we talk about that and then the opportunities. With that, let's dive into the meat of things. The planning process for Windows Server 8 was a little different than for most of the other releases. And one of the key sort of driving key inputs into the process was we did customer-focused design sessions. So we sat down with a lot of our key customers and sort of probed them in a very sort of formal way about their input on what's really important to them. What are the important scenarios? Where would they like to see progress? In the end, we ended up visiting over 6,000 customers. And we sort of, then when you get a lot of that data, you usually end up, you don't know what to do with it. And so we started to categorize it, put it into buckets to sort of get sort of what are the main themes of what people are after. And this sort of resulted in 22 areas of investigation. But the number one thing that everyone wanted is continuous availability. They all talk about it in slightly different ways, and there's slightly different things they want, but every single customer had some ask around availability. So that emerged very early on as one of the strongest themes. Some countries, it's so overwhelming, it's basically a must-have. So Germany and Japan in particular, they basically say, well, we're not gonna buy this unless sort of all these things get done. So we got very, very, very strong feedback and very detailed feedback as well. And so based on that, we then prioritized some of the work we did, so just sort of hearing from our customers that this is what we need to do. Continuous availability, we had done long discussions internally. What do we mean by that? In the current release, we sort of have clustering and high availability, but what does continuous availability really mean? And it's like, what's the customer expectation around it? And it's sort of, it doesn't apply to like just the OS. It applies to like the whole system. It's an end-to-end view. So it's a combination of the server hardware, storage hardware, networking hardware. And the expectation is that you can basically transparently fail over, either for planned moves or for sudden failures, without any sort of loss of data. And transparent failover is then sort of the next term you have to define. That's basically mean that whatever happens to the system, there's no visible errors that are bubbled up either to the user, to the end user, or to the application. You never lose any data. And while things are failing over, your applications still run. So it's not like you have these long brownout periods where like everything stops. No, people want to basically have their services continuously up and running without any interruption. That's a pretty high goal, and we will take steps to get there. But for sort of the platform pieces and a couple of the core services, we designed that as our goal into the system for the next version. The other observation is there's sort of a little bit of availability for everyone. So it comes sort of in these ranges. And there's like two big dimensions. When sort of availability as sort of a means of hiding from errors and hiding from problems, there is sort of an SLA that goes up. So you can lose a power supply, you can still work. Or you can lose a node. You can lose a NIC port or a network segment cable. And there's more and more hardware that you might have to sort of put into the system to survive those different error modes. So on one dimension, you can basically get your SLA up, your service level agreement, but then the complexity of the system might go up as well. So at a high level, simple way we thought about it, you start with a single node, and there's lots of things you can do on a single node. You can isolate a broken network adapter. You can isolate even a memory module. You can sort of mask failures on a single node. And we did a lot of investments around that, trying to basically get a single node much more available than it is today. Little statistical fact is 85% of almost all servers ship with 2 NIC ports. 85% of the servers only ever plug 1 NIC port in. Why? Well, it's relatively hard to actually configure that system to make it continuously available to get that out. So another dimension that's not visible here is sort of like even if you have all those hardware investments, then being able to configure the system that you actually have the benefits of the availability to you is not that simple right now. So on top of doing the hardware investment, we also made the investment reducing the management complexity to making these things available. And we talk about that more. So on the local node, you probably saw a little bit in the keynotes, there was a huge investment in the storage stack to begin with. So the storage subsystem on Windows, Windows Server and Windows got a major overhaul. And there were a lot of investments to improve the resiliency of the storage subsystems that are going to pay out for everything, for all the workloads, for everything. In the networking side, we added a whole bunch of features. And in the kernel, we sort of spent a lot of time doing sort of that device isolation and memory isolation. There are things you cannot mask. Like one of those boxes goes down, and you will have to find like a way around it. They are very, very, very expensive hardware solution where sort of you run like dual hardware in lockstep, but that was not our target. Our target was not to make availability at any cost, but to make it available at an attractive price point. So in order to mask sort of catastrophic failure of a single box, you just need to do scale out. So next step up, if you can't mask it on the local box, you need to have a cluster. So we took a good look at our clustering solution that we had in R2, which has been very successful and sort of growing capabilities over the years. But then we went back to the definition, continuously available. So what are all the things that were in the way of sort of masking sort of that failure of a box completely so that an application getting a service out of a cluster would not see a single error? And that took a lot of work. And then finally, your site goes down. There's areas where power is just not very reliable, and you can try what you want, whole sites go down. And if it isn't sort of, if you have a UPS here, then sort of your network link goes down. But the next step up really is you need to have multi-site systems where your services are distributed, geographically distributed. And we took investment there as well to make that easy. A lot of these things might be available today, but they come at a price and complexity point that is just not accessible to the average customer. So a lot of our investments were driven around that. So this is the overall landscape that we're going to talk about. And we sort of bring up this like very, very simplified stack view of the operating system and just walk you through sort of the main investments and the main areas or touch points with our partners of where they can basically engage with us. The tenants I talked a little bit about. We wanted to broaden the market for availability, make it available to everyone. Everyone should be able to get a little bit of availability. And then depending on your needs, you sort of you can walk that continuum to get higher availability. That's sort of the key point. One of the ways to make it more, sort of bring it to more people is to not require very specialized hardware. So a key design point was to only rely on commodity components to make sure sort of it's readily available. APIs and partners are really important on this. Microsoft as a company can only go that far. At the end of the day, it really depends on the boxes you run on and sort of the whole environment. So we are, for availability, even more dependent on our partner than we have been ever before. And so this talk really kicks off a series of 6 talks around CA where we sort of drill in these different areas. And sort of I will introduce these areas where we have partner opportunities and point you to the follow-up session where you will get the drill down. Manageability or procurement. One interesting feedback was from customers, I don't actually know what I have to buy. Okay, so I want a reliable system, but I wouldn't know how to buy it. Like, what do I buy in order to get an available system? Well, you could imagine a world where you go to one of our partners' websites and you can actually buy a completely configured, a high availability system. That would be a nice world. Today, that's not for the faint of heart. So that was one more vector we're trying to get to. We're building all encapsulating form factors that are integrated as appliances, as high availability appliances. And we talked a bit about the different layers. Good. With that, let's dive into the first layer, which is the storage platform. And so if you see at the bottom, we got the link to the follow-up session. So if you think this applies for your specific business, please sort of go to the follow-up session, and the folks from that specific team will be there for a really deep drill down. NTFS has been around for a while, has been optimized, and has been made very, very resilient over the years. But there were some issues that sort of have been long lingering, and some changes happened. And let's start with the drives. Back at the days, this was all designed for SCSI, and there was a certain set of commands that just every drive implemented. Turns out, SATA became really, really popular. And what we found, despite our best efforts, some SATA drives just don't implement certain commands. There's nothing we can do about it. The way the file system was written, that resulted in some variability with stability. We have like some assumptions about write log consistency. And so we put in the work and really make sort of the probability of like corruption with SATA drives lower. The core storage management with the volume manager has been around for a very long time. What changed is that the number of drives people want to connect to their Windows boxes has gone up dramatically. That became a very tedious task. So with the investments in Spaces, you saw that probably in the keynotes, we now have new abstractions that very easily allow you to pool your disks and then sort of carve out thinly provisioned virtual disks out of that. And that's a big step for us. That's a really big step where we sort of make some core investments in the layer. And that investment doesn't just work on the local box. No, it works on clusters. And the idea was to basically build it in a way that immediately gives you that continuously availability. Check disk, another interesting area. And sort of we made some investments there. And in certain configurations, you can completely mask that check disk is running. There's no interruption to the application whatsoever. For the longest time, we have been having a very close relationship with the storage industry. To complete our server scenarios, you buy a server and you buy an external storage array. And now those devices have become much more intelligent too. And there are, of course, ways where you can, when you work together nicely, can offload a lot of tasks directly into the storage array. A lot of the time today, the data is just being sent from the storage array to the computer and directly back. If you can offload that, there's a lot of things you can make really reliable and really fast. And one of the other themes that came while we talk to customers is efficiency. Turns out like storage needs or storage capacity has been growing a lot faster than disk density. The result was that people ended up having to do a lot more investment in their storage capacity than ever before. So that utilization argument became really, really strong. So how do we make sure we get the most out of our storage? So while you want to get the availability, you also need to make sure that you're really efficient with the resources that are given to you. So you invested into thin provisioning, vital storage optimizations, and data deduplication that allow you to store the most amount of data on the smallest amount of disks, or make that elastic so that you can basically buy the disks as you go, as your storage fills up, and you don't have to have that big investment right at the beginning. Getting next up to the stack is clustering. And clustering is a difficult topic. It's a difficult technology. In the last release, we invested heavily in the UI and the ease of deployment. But when you really get down to it, there is this difference between continuous availability and high availability. And high availability is this model where you lose a node, and after some time, you can bring the node back up, and you can restart your application, and the service is restored. Well, continuous availability is very different. In continuous availability, the node goes away, but nothing restarts. There's no repair phase, no rollback phase. It just immediately continues without any visible interruption to the application or the user. That comes with some additional baggage. And one of the design principles in Windows is you can't hold timers. So once an I/O has been scheduled, that I/O has been scheduled, and there are certain timeouts for when it has to be completed. Well, what that means is, well, you better fail over before all these timers expire, which means that the time budget you have to do a cluster failover turns out to be very, very small, in the range of like 10, 15 seconds. Not a minute, not 2 minutes, no, 10, 15 seconds. If you can do that, then you can basically hold the I/Os in a way that is completely transparent to all the applications and the users. Now, how do you get from where we were now to 15 seconds, where you really have to go to every single step the way and manage your time budget for these failovers very carefully? And it might require putting exactly the right hardware in there. That's where those time budgets are being met. So don't expect you buy a garden variety server and this will work. So that was one big investment, getting the failover times in clustering down into the seconds range for relatively large storage configurations and network configurations. In Server 2008 R2, we shipped a technology called clustered shared volumes that I assume most of you are familiar with. And this gives you a single namespace for drives that are basically shared across all the nodes. They're visible to all the nodes. There's direct I/O possible to all the nodes, and it gives you a single namespace. That's a technically challenging proposition, and to reduce the surface area for that, we made that available for Hyper-V only. In this release, CSV is actually designed to support all workloads. Arbitrary workloads can run in active mode on all the nodes of a cluster and see the same disks. And one of the applications that is going to take advantage of that is a new file server, which then now exists in a scale-out mode that is completely active, where basically you can get to all the files from all the nodes. And And another interesting feedback point from our customers was they all love Patch Tuesday. Every single one of them told us how much they love Patch Tuesday. And particularly if you have a clustered workload, that just throws a wrench into it, because you have to bring the cluster down to patch the nodes, and that's a very manual and cumbersome process. Well, continuous availability, you should be able to do that without ever losing any of the services provided by the cluster. And so, again, we build a component that allows us to subscribe to the stream of patches, but then have a workflow automatically patch the cluster in a rolling thunder fashion, where the workloads migrate from node to node without any visible interruption to the end user. Session 450 is sort of where you can learn more about these technologies. On top of that, we got our real workloads. Like, we're not doing that just for the purity of the technology, but so that was driven and the work was prioritized by a couple of key workloads. So what are the things that really bring down SQL, that really bring down Hyper-V and the file server? So what are all the things we need to basically get going there end to end to make those things available? And so those are the big Microsoft workloads, and the reasons for disruption come from many sources. So we dealt with the support organizations and mined like all the large databases. We worked with our OEMs and their support organizations, trying to reduce the load there, and really sort of getting a handle on sort of what are top-down, like percentage-wise, what are the reasons of why things are down. And that's one good metric to look at. And the other good metric is, like, if you're down, what are the cases, the root cause analysis of what takes a long time to get back up. Both of those you need to minimize. Like, minimize the case you go down, and definitely minimize the time it's going to go to get you back up. So we did that, and there's some common themes, right? You got to be able to tolerate the loss of a node. Just node completely goes away, should be invisible to the end user or to the application. Requires a lot of work. We invested the work and did that for the file server. And so at this point, you can lose a file server and it's not going to make any difference. Your app continues to run. Network fault tolerance is a simple term. It's very difficult in practice. There's many different things that can go wrong in a network. And so we invested in a variety of technologies to bolster up that network fault tolerance. NIC card can fail, network segments can fail, switches, routers, there's all sorts of things. And so dealing with that in a holistic way was quite an investment, but we got it very far down the road. Storage is the other big part there. Our clustering technology requires shared storage in some form. And so the technology of choice in the past has been some form of a block array, either be Fibre Channel or be iSCSI. And in fact, the only supported storage solutions for these clusters for remote storage for Windows Server 2008 R2 are block storage arrays. Well, that works really well, but there's a certain complexity point attached to that. Like, the average Windows administrator isn't necessarily sort of very well versed in the technologies and how to set them up to actually get that to high availability. So we took the next step. I'm going to make available sort of high available storage for clusters just based on our file server protocols, so that an average administrator can just out of the box set this up without any additional knowledge. And we're going to make it work on relatively commodity components. So standard server components will be able to let you do that. Latencies are always a big thing. And then this whole high availability hardware game often deals with redundancy. And then you sort of have two modes. You either basically have one blade running and the other one is in standby mode, but that's not really very good utilization of resources. Ideally, you get to a mode where you can run them both in parallel so that you can do load balancing. And you still need to do your maximum capacity planning, but for most parts of the operation, you actually can take advantage of the benefit of having the dual hardware by getting better service. So when you think about having multiple links on a network, yeah, you can either use one at a time or you can use all at the time. So while we're at it, we're also building bandwidth aggregation over all possible links into the protocol. Last but not least, when it comes to backup, at the end of the day, you do want to have backup. There's just no way around it. And when you introduce all these new storage technologies, you need to make sure that your backup applications still run. And in the past, we had everything focused on local block storage, and our VSS technology that allows you to do application-consistent snapshots is very much tuned towards those assumptions. When if you go to a file server, you now basically have a remote storage system. In order to make your backup applications work, you somehow need to be able to remote that whole VSS mechanism to the remote side, and we did that as well. Session 444 is where we follow up on this specific topics and go drill really, really deep in like what's necessary there. Microsoft is not alone on this world. We're very, very well aware, and we have like deep partner engagements and deeply engaged sort of with the standards community around the like all the other protocols that exist. And almost every single of our customers does not have a homogeneous environment. So it's a heterogeneous world, and we realize that and we acknowledge it. And so we added a lot of these continuous availability features, not just in our own protocol stacks, but into the other protocols that we support, namely NFS and iSCSI as well. So with Server 2008, the iSCSI target that in the past was only available on a separate SKU is now integrated into the server itself. And that supports basically transparent failover for a variety of scenarios, and in particular not just for Microsoft scenarios, but also for VMware scenarios. And the same is true for NFS. So VMware supports failover, continuous failover on NFS v3, and we have implemented all the changes necessary to make that work as well. And the message here is when you want to build NAS appliances based on Microsoft technology, we have a pretty full-featured release that will allow you to basically take more or less standard server hardware and get to a very, very attractive price point for those solutions. Scale out. I talked about the next version of cluster shared volumes, the CSV v2, and that allows you to export a single namespace of your LUNs to all the nodes in a cluster. Cluster size, as you saw, we made some progress. We can go up to 63 nodes in a cluster, and you can have a single namespace all across. And the big difference is it allows you to have active access. Instead of failing a workload from one node to the next node to the next node, you can have it active parallel all the nodes at the same time. And we implemented that mode for the file server. So with the SMB 2.2 protocol, that is also supported by the clients, that's the clients can basically round robin and distribute evenly on a cluster, which allows you to get much, much, much higher scale. And again, very, very fast and transparent failover in active mode across the nodes. This technology works, again, for file servers, but it also works for local application. So if you run Hyper-V directly on top of this, you get the same benefits. If you run SQL on top of it directly, you get the same benefits. So think about it as the capabilities of the local file system are seamlessly extended via SMB 2.2 at the remote side as well. And then it depends on the scale of the application, the scale of your deployment, whether you have a small local cluster or whether you have like a separation of the compute cluster and the storage backends. And again, session 444 is where we drill more into the details. Our file servers have been around for a very long time, and in the last couple of years, what we have seen is a trend that people want to consolidate them. So you don't want to have 1,000 file servers, maybe you want to have 5. Well, it turns out, once you've done that and you lose one of those, you just took out 200 people's file servers. So the trend to that consolidation puts a lot of pressure on making these things highly available. People really only are doing that if you give them very, very, very strong guarantees for availability. And we sort of looked carefully at that scenario, and there's sort of this desire to having a single namespace, being able to manage these systems very simple, because there's a big cost sunk just in managing all these different systems. So we invested heavily in like a single pane of glass, new management infrastructure to make this very simple for very large file servers. And another area that we're got a lot of feedback on is compliance. As sort of the governments around the world ramp up their game in terms of data privacy and like how you have to treat data, we have to respond and extend our platform to allow companies to actually comply with that. And while that's possible on the current platform, it's not exactly easy. And we added a component about dynamic access control that will allow you to centrally have access policies that will enable you to much, much more easily stay in compliance with your data retention and access policies on the data. The consolidation scenario, what we're seeing are sometimes relatively stunning numbers. So we had one customer that went from 1,000 file servers to 5 file servers. That's huge concentration. And they're really not going to basically take these file servers, run virtual copies, let the old stuff run. Or they really want to consolidate all that data. But then the pressure to have those things up and fast to a very, very large number of customers is pretty high. So when you think about the productivity of all the end users, and mostly it's Office files, what they're really interested in is sort of like when I open the file, when does Office come up? And so when you do that for 20, 30,000 users on a file server, that's a lot of work to make sure that the latencies that you see, like the observed latencies for the end users go down and go fast. So we started with that process in Vista, but we put in a lot of additional investments in the SMB 2.2 protocol to optimize for that Office experience on these large file servers, and even on when you have a WAN link in the middle or like a slow and flaky network in the middle, that sort of the perceived performance is very, very high. We talked about networking, and a lot of the networking resiliency comes from hardware. So you can basically have multiple links and redundant hardware pieces. But as we actually learned here when we set up the stage, the bit bar, a lot of resiliency also comes from some of the infrastructure services. So setting up DNS DHCP in a way that is highly resilient can be challenging as well, and has been challenging in the past. So with Windows Server 8, one of the things we add is very, very simple high availability for the DHCP servers. And like as one of the core network components sort of that you rely on, having that simple and reliable turns out to be pretty key. And we're following the standards, the IETF standards there. There was like a way to do that with clustering, and now sort of it's really, really simple. The network component failures for the last, 10 years or so, there have been solutions shipped by vendors. So NIC teaming solutions by Intel and HP have been widely available, but of course they're all a little different, and it all makes you require that all the NICs come from the same vendor. I think we finally sort of saw the light, or customers told us where the light was, to make sure that we put that into the operating system and just make it part of the normal setup procedure. So when you set up your server, setting up NIC teaming, even across different heterogeneous NICs, is now really, really simple. And the switchover times are very, very fast, and it's a very, very fluid process. And then on top of that hardware redundancy, you now need to think about that your protocols or your workloads are actually taking advantage of those redundant network paths in a way that's completely transparent. It's not automatically given that when you have multiple interfaces available, that a specific server application would actually use those redundant connections and automatically detect them and work through them. So we added that functionality to SMB 2.2 to basically take full advantage of multipathing over like any connected path. And there's some intelligent rules to make sure that you get the most bandwidth out of it, and that you are very fast in switching up and down these different network connections, so again, that the applications don't see any interruption. It's completely transparent to the app, whether these network links come up and down. In fact, you can go as far, you can start with one cable, and if you see it's too slow, you can just put another cable in, and just on the fly, it will immediately take advantage of it and run at twice the speed. The session where we go into the details on this is like 446, and there's going to be some more interesting drill downs into all these technologies. Hyper-V. Hyper-V, we came a little bit sort of from behind, you could say, but it's still early in the market. So the virtualization is a technology that's still emerging. And in this time around, we are having made a big investment in all the Hyper-V features, particularly around sort of the storage subsystem and resiliency. So in the past, we had the technology called live migration that allowed you to migrate a live workload on a CSV cluster. With the next version, Windows Server 8, we allow you to basically just migrate onto any machine, whether they're in a cluster or not, which is a pretty amazing technology. So the key thing to keep in mind, on CSV you have shared storage. If it's two arbitrary machines, there's no shared storage. So you can sort of live migrate between that. And that's true as long as the storage actually happens to be an SMB 2.2 share. We talked about that geo-replication scenario where people need some form of disaster recovery if a whole site blows up. So on top of sort of this live migration scenario, where you end up always having one instance, we put right into the hypervisor at a very simple to use way the ability to replicate a whole VM and all its attached storage from one site or one node to another node. And it's really as simple as right-clicking on a workload in the Hyper-V Manager, pointing it to another node, and then in regular snapshots, you get an application-consistent image of the storage and the VM that can be restarted at another node. Customers are very excited about that. The technologies that exist today are usually very expensive, but the big part is the manageability of those components. It's very hard to do that today. And with that ease of use, just right-click, replicate. It's a one-click operation, and we've thought through all the cases of sort of trying to fail over, failing back, making this really seamless for customers. Running clustered applications inside a VM was like one of the barriers where we had some issues in the past because the only technology on which that really was supported was iSCSI. We have that shared storage requirement for clusters, but once you run inside a Hyper-V, how do you get to that shared storage? And there was no pass-through mode for the fiber channel LANs. And so what we added for customers that do have fiber channel SANs, that we had the ability to sort of project those fiber channel interfaces into a VM so they can now run workloads that are clustered as guests in Hyper-V. And so we think that that's also going to make a big difference of driving virtualization and allowing people to continue with the HA applications that they have. And again, there's a session 451 where we talk about all the Hyper-V sort of requirements for building HA systems to make that run really smooth. I talked about a lot of technologies, and there's a lot of new words, and just want to highlight a few of them. So we talked about SMB 2.2. There's a new version of the file services protocols that are from the ground up designed to support continuous availability. We had the storage subsystem where there's a whole variety of features that enable a lot more resiliency on the local storage. And there's fast check disk, there's a lot of things there, storage spaces. We have the offload features to intelligent arrays. We have the cluster-aware updating, all the cluster technologies, the CSV v2. We got the Hyper-V replica. We got the storage live migration that now don't even require clusters anymore. So there's a lot of new technologies, and they all somehow come together to enable that end-to-end CA scenario, the end-to-end scenarios that we talked about. With that, I want to now switch over and talk really about the specific opportunities and give you some examples of sort of the partnering opportunities that actually led to bringing this release forward so far. So let's talk about storage. For servers, there's always a range of sizes and machines and deployment options, and usually starts off at a single discrete system. And at a single discrete system, what people are mostly concerned about really has to do with like being resilient against disk failures. And traditionally, like disk failures, you're resilient by using hardware RAID, and we continue to support that. But with Windows Server 8, we also added a new virtualized storage layer called Spaces, where you can get a lot of functionality that you're used to with hardware RAID now directly built into the system. And let's see, the concept of basically taking a pool of disks and then carving out thinly provisioned virtual disks out of that, where you can select sort of the resiliency level you need. And so we believe that's going to be pretty attractive. There are some guidelines required for the JBODs to drive those things. And sort of the key workloads for that is the Hyper-V server if you run it locally and the file server. Going up the stack a little bit, you're getting into these clustered configurations. And for clusters, as we talked about, in the past there only was the fiber channel option, which actually for most parts already pushes you like high into the enterprise space. Well, now we believe sort of at the lower end, there's a new opportunity to sort of create like integrated solutions of clusters that are not reliant on fiber channel. And again, we have two solutions. The virtualized storage layer Spaces can work on clusters against shared SAS JBODs. Or I'm going to drill down into that a little later. There's a new device class of clustered PCI RAID. Many, many years back, we already supported sort of the notion that you could have PCI RAID controllers in a cluster. But back at the time, that project was not very successful, so we make another round at it, and we spend a lot of time making sure we understand like all the error modes that happen when you're sort of on these clusters. And the reason for doing that is really driven by some of the demands of the workloads. When you think about a file server cluster, and again, continuous versus high availability, that means at any point in time, you can lose a node, but you can't lose any data. Well, when you think that through, that means like every write that has been committed needs to show up on drive, and you can't do any caching. So for clustering, we have to completely disable all the system caching. Well, when you lose all the caching, you're giving up a lot. Well, the idea is you can bring some of that back if you push the caches down into the hardware. But then if you lose one node, how do you get the content of the cache? So that new device class really works with hardware mirroring at the caches to enable you to do that. And it gives you some of the performance back that you lose by by turning off all the system caching. And so for clusters in the low end, you can either do Spaces, or for certain workloads that are write intensive and where the write performance really matters, we introduced this new device class of these clustered PCI controllers. And I will show you an example, or we'll show you two examples later on. Then in the higher end configurations, we have the enterprise and hosted cloud scenarios where we pretty much believe this is going to be more traditional systems. The clustering, sort of setting it up from the parts and pieces, can be a little daunting. However, as some of you saw on the show floor, we came up with like a new integrated way of doing clustering where you basically can do it in all in one box. In fact, there only might be a single display port and keyboard port, but it still is a cluster. And with all the management investments we did in Windows Server 8, you can hardly tell that it's not a single node because everything is treated as a single entity. And so that is kind of the form factor we envision to roll out into the smaller customers. In fact, ideally, sort of you go to like one of the OEM websites, you say, well, I want a file server or I want like a continuously available file server, and there really isn't much difference. And most customers hopefully would choose the continuously available file server because there's a really great value proposition for them. Going up the stack, we're probably getting sort of into more traditional cluster space. Shared SAS can actually scale up relatively nicely. So on top of just doing the existing fiber channel, SAS switches scale up nicely to sort of like up to 8 nodes. That's what we have tested and where we saw pretty nice results. So you can basically put together your clusters based on shared SAS switches, and that might sort of be an attractive, price-attractive option. But at that point, sort of you're getting to the data center. And then for the higher end, when you're talking about external storage arrays, that's sort of the existing technologies. And interestingly enough, a lot of the investments in clustering pay back over there as well. So the failover times and the switching led to a huge scale. And there's a typo on this slide because we're going up to 63 nodes per cluster now. Okay. Now let's talk about some of sort of the exciting new hardware I brought with me today. And maybe I can get a shot of this box. At the Discover conference in June, we made an announcement, or HP, one of our partners in the storage server space, made an announcement for the X5000 box. And that's sort of running 2008 R2, our current version of the operating system. But it sort of is like a groundbreaking system in that it basically integrates 2 nodes, 2 blades, all the storage, shared SAS, and clustered PCI array controllers all in a single box. There's a single display port. You set it up from unpacking it to getting it to run in about 15 minutes. And that means 15 minutes with all the clustering being configured, all the storage being configured, up and ready to share files. And so we did a lot of joint work with HP, actually trying to optimize and making that work, and understanding for these clustered PCI array controllers, like what does it look like? Like how do you qualify that these things actually work? Or going through all the error modes and understanding that. And out there at the bit bar, like at the expo floor, you've probably seen there's sort of like this fishbowl case where we demonstrate one of these systems, and it's basically serving all the downloads from the attendees who want to download images. And so we were happy to basically get one of these prototype systems and put Windows 8 on them. And so all the work we did in the investments in 2007 R2 actually carry through. The difference is now you basically get a CA file server right out of the box. So this system, I expect, I can't speak for HP, but I expect will be available with Windows 8 as well, where you get advantage of all those features. We have on the show floor at the HP booth, we have a presence, and Jim Hankins is there from HP. And if you have additional questions, please follow up with him. He will be more than happy to walk you through the details of how that system works. Excuse me. In addition to sort of a specific OEM design, we have done a joint project with LSI and Wistron, actually, to work on a reference design for one of those integrated 2-node clusters. And that's sort of rather sort of nondescript looking box at this point. And it's again sort of similar technology. It's two blades, and then it has just like standard slots. So it has PCI Express slots. And as you can imagine, out of this box, again, you have shared SAS, a bunch of drives in the front that are accessible from both of these blades. All the drives are visible to all the nodes. And have relatively beefy nodes, so you can imagine this both running Hyper-V locally or being the platform for a file server. And this is a reference design, so it can be taken, and if you're interested, you can contact either John Lovell at Microsoft, or you can contact Joseph Chow at Wistron. And that is one of the typical like sample products that we would like to see our partners bring to market for making all these investments that we put in the operating system really accessible to the end user. Well, one thing's missing in here, and that is sort of that storage controller that enables to do that failover stuff. And so we had a cooperation, a long-standing cooperation actually with LSI. And so while this looks like a traditional MegaRAID card, it's like a MegaRAID card with some secret sauce in it. And the secret sauce is that we had a joint development project with LSI where we worked on making sure that that clustered PCI RAID functionality is actually implemented on these controllers. And so that you can build these two-node clusters with inactive-active mode, just based on standard PCI Express cards. And again, if you're interested in building a box, or sort of this card, for example, would fit nicely in here. We have Thomas Hammond Doyle is here from LSI, and his contact information is given there. And please follow up with him. I also have a bunch of flyers here. LSI doesn't have a booth, but you're more than welcome to stop and have a flyer at the end of the talk. At the very top level, a lot of the technology that we're doing here is driven by shared SAS. And so in order to get like nice integration with shared SAS JBODs, that's really, some of these boxes have it internal, but you could also imagine that you have external JBOD boxes. There's just a few sort of special things we require for management integration. And there's sort of, one thing is you want to have SES support. So once you have like a lot of these drives, you want to know when the operating system finds a drive is broken, there needs to be a red lamp going on. So please, like when you're interested, look at cases that support that. We will support it in the OS, so to make the management part easy. There are some requirements that come out of clustering, specifically persistent reservations need to be supported. And so that's one of the requirements. And there's many JBODs out there. They're not created all the same. So before you sort of jump, please contact Matt Garson. He's a program manager in our storage team. And they're happy to walk you through the detailed requirements of like what the hardware should look like if you want to build a box around that. We're working with, of course, all our partners. So we are in some active discussions with additional ODMs and OEMs. And so if they have a variety of systems scaling up to 2 nodes, 4 nodes in this completely integrated form factor. And so they can get up to pretty beefy boxes. And we will probably talk about that like over the next year or so, give you more information like once we have things to announce. We love to have more partners. So if you're interested in engaging in these discussions, please either contact John Lovell or Paul Luber, and we will be happy to follow up and sort of have like more in-depth sessions with you on what it takes to do this. And that could be either like picking up the standard ODM design, the reference design we did, or doing your own. Talking about the network side of things, I brought some interesting examples here. We have from Intel the NE020 NetEffects card. And the interesting thing about that, it's a 10 gigabit Ethernet adapter, but it supports RDMA. You probably remember seeing in the keynote, there were some, in Satya's keynote, where he did storage live migration and showed you some of the bandwidth. And so getting high bandwidth is one thing, but then having the CPU associated with moving all those bits around can get very, very high. I think you might remember there was like 2.5 gigabytes of data being transferred, but the CPU was less than 1%. Well, how did that happen? Well, the magic behind that happening is actually RDMA. And what the result of that is, when you have your Hyper-V or SQL box, it's not spending all its CPU on moving the I/O, but it's spending its CPU cycles on running more VMs or giving you faster SQL results, and then using RDMA as the technology to route over the network. That adapter is available today for the Network Direct HPC environments, but for Windows 8, we will integrate RDMA support into the kernel. And if you're interested in playing with that card, please contact Intel, and David Fair will be more than happy to follow up with you there. Now we're getting sort of into science fiction land. What I hold in my card here is it's really a small card. Is a dual band 14-rate InfiniBand adapter. So this card here has 112 gigabits of bandwidth. So the biggest part on it is actually connectors. That takes most of the space. But these are incredibly fast. This is also a PCI Gen 3 card. So as you're probably aware, so there's a big change, technology change happening right now on the platform and the chipsets. So with PCI Gen 3, sort of you don't hit the bottleneck of like roughly 3 gigabytes per second on the PCI slots, but you can go a lot faster. So you can imagine when you run your file protocols, like SMB 2.2 is supported running over SMB, and you put a couple of those cards in your storage backends, that can account for a lot of bandwidth, and the CPU overhead is extremely low. So we are experimenting a lot with these, and they can also, like in addition to doing the 56 gigabit InfiniBand, they can do Ethernet. And while the Intel solution is doing iWarp, so it's routable, the Mellanox cards are doing Rocky, so that's a local link technology, so it's not routable. It's more like a top-of-rack solution, and then you would like need an interface, a gateway to sort of do the traffic over Ethernet. But for really high-end applications, or if you want to integrate like your compute servers with a top-of-rack storage box, this is a very, very, very price performance-aware technology. When you look at like some of the 10 gig Ethernet cards, price point in the market, you go to Google them, it's probably like $600-700 for a controller for 20 gigabytes. Well, this is not the multiple in terms of what you get for bandwidth. And so this is very attractive. We're seeing incredible latencies on these cards too. So the under high load, having a very predictable latencies is the other big thing you want for storage. And with RDMA, with the hardware acceleration, that really shows in the latencies. So you get like low microsecond latencies. And Gilad Shiner from Mellanox is the contact here, and he would be extremely happy to talk to you if you have any interest in building systems around this. Okay. Overall, it's not just about individual components, but to integrating all of those into these running systems. So we are rolling out 2 new programs for like the end-to-end design of these high availability boxes. And so there's going to be a certification program for storage spaces, if you want to build a box that is built around storage spaces, and that's Matt Garson. And so there's a whole bunch of guidelines for like what the hardware, compatible hardware looks like. And if you want to build a system around some of these clustered array controllers, and then the contact is John Lovell, and we're sort of rolling this out now to some of the early partners. So please get in contact with us if you're interested in doing any of this. And these are brand new programs, and we're in alpha. So I just want to set expectations. Please work with us, give us feedback so we can get better to basically bring the best quality that we have to the customers. So let's just wrap this up. In terms of the opportunities, we got the RDMA adapters. That's one partnering opportunity. There's a lot of contact points around external storage arrays. That's the offloading, data tiering, and smart hybrid LUNs. On top of sort of the technical innovation, we also a while back joined the SMIS working group, and so we decided to put all our management story completely based on standards. So we're implementing SMIS as a standard way of doing that, and so that of course will require some working together on making sure your arrays are fully integrated into that. And then for systems management, like usually Windows has like some inbox functionality, but it also integrates well with external management suites. So there's a couple of contact points there where we sort of would like to hear from you and work with you on that. And then we have the SaaS the SaaS cases and the integration there, and doing some integration with the Windows Storage Management APIs. Replication vendors, host-based and array-based, backup VSS, and the HBA vendors on the, basically all the hardware vendors. What we find is a lot of these machines actually need firmware updates. Well, with our cluster-aware updating, there are APIs where you can plug into the new cluster-aware patching process, so you can basically roll patching, upgrading the firmware on your machines without actually ever interrupting any services. But that will require like writings to specific APIs. And so if you're interested in that, please contact us, and we'll help you get that done. That's my last slide. As I said, I'm kicking off a series of 6 talks. And this was sort of more the introduction to basically sort of introduce you to the whole space and whet your appetite and also direct you sort of to your specific area of interest. We got 6 talks coming, and at the bottom of the slides I put in the right links. I hope you found this useful and entertaining. And with that, I would like to thank you very much.